Predicting Customer Churn, Unlocking Insights with Machine Learning in Python. Hey there data explorers. Buckle up, because we're about to dive into one of the most impactful and exciting projects in the world of data science, customer churn analysis and prediction using machine learning in Python. In today's fast-paced business landscape, keeping customers is just as important as acquiring new ones. But what happens when customers start leaving? That's where customer churn comes in, the silent killer of growth and profitability. The good news: with the power of data and machine learning, we can predict who is likely to leave and why, giving businesses a fighting chance to take action before it's too late. In this hands-on project, we'll be working with a real-world customer churn dataset to uncover hidden patterns through exploratory data analysis (EDA), clean and transform our data with feature engineering, and then build powerful classification models using some of the most popular machine learning algorithms like logistic regression, random forest, and XGBoost. We'll train our models, test them rigorously, and finally, evaluate their performance using advanced metrics to find out which model reigns supreme. Whether you're a beginner looking to level up your skills or a seasoned pro brushing up on fundamentals, this project promises to be both fun and full of valuable insights. Ready to become a churn-busting data hero? Before starting, don't forget to subscribe so you can stay updated with all the latest AI-related projects and other content. Now let's get started. In this first step, we're going to load our dataset and take a sneak peek at what it contains. Think of this as opening a treasure chest filled with clues about why customers might leave your business. Are you ready to uncover these insights? Let's get started. Why it matters: understanding the structure and contents of your dataset is the foundation of any data science project. By exploring the data upfront, we can identify key features, spot potential issues like missing values or inconsistencies, and start forming hypotheses about what might drive customer churn. This step sets the stage for everything that follows: EDA, feature engineering, and modeling. What to expect in this step? In this step, we'll load the dataset using pandas. Use the dot-head method to display the first few rows of the data. Get a quick glimpse of the columns, data types, and initial observations. This will help us understand the structure of the dataset and familiarize ourselves with the variables we'll be working with. Let me tell you a fun fact. Did you know the term churn originated from the telecommunications industry, where it referred to the number of telephone lines disconnected each month? Over time, it evolved to describe customer attrition across various industries. Today, reducing churn is one of the top priorities for businesses worldwide because retaining existing customers is often cheaper and more effective than acquiring new ones. Real-life example related to this step: imagine you're working for a telecom company like Verizon or AT&T. You've just received a massive dataset containing information about your customers, such as their demographics, service plans, payment methods, and whether they've churned left the service. Before diving into complex analyses, you need to understand what's in the dataset. This is akin to flipping through the pages of a book to see if it's worth reading further. By loading the data and taking a quick look, you can determine if the dataset contains the information you need to answer critical questions like: which factors are driving customers to churn? Can we predict who is likely to leave? Let's test your data exploration skills, students. Question 1. What does the dot-head method do in pandas? A displays the entire dataset. B displays the first few rows of the dataset. C displays only the column names. Question 2. Why is it important to explore your dataset before diving into analysis? A. To make the code run faster. B. To ensure the data is clean and relevant. C. To impress your colleagues. Drop your answers in the comments. I'm excited to hear your thoughts. Speech balloon. A pro tip for you: when working with data sets, always start by understanding the context. Ask yourself, what problem are we trying to solve? What does each column represent? Are there any obvious patterns or anomalies? This contextual understanding will guide your analysis and help you make informed decisions later on. What's happening in this code? The code block performs the following tasks. Import libraries. We import essential libraries like pandas, numpy, matplotlib, and seaborn. These libraries are fundamental for data manipulation, visualization, and analysis. Pandas, for handling and analyzing tabular data. Numpy, for numerical operations. Matplotlib and seaborn, for data visualization. Warnings. Filter warnings. Ignore, suppresses warning messages to keep the output clean. Load the dataset. We use pdread_csv to load the dataset from a CSV file. The path to the file is specified inside the function. Inspect the data. We use the .head method to display the first few rows of the dataset. This gives us a quick overview of the data structure, including column names, data types, and sample values. The output shows the first 5 rows of the dataset. Here's what we can observe. The dataset contains various columns related to customer attributes, services, and churn status. Key columns include gender, customer's gender male/female, senior citizen, whether the customer is a senior citizen 01, partner, whether the customer has a partner yes/no, dependents, whether the customer has dependents yes/no, tenure, number of months the customer has been with the company, phone service, whether the customer has phone service yes/no, multiple lines, whether the customer has multiple phone lines yes/no, no phone service, internet service, type of internet service DSL fiber optic no, online security, online backup, etc. Additional services the customer may have. Contract, type of contract month to month 1 year 2 year. Paperless billing, whether the customer uses paperless billing yes/no. Payment method, method of payment electronic check, mail check, bank transfer, automatic credit card, automatic. Monthly charges for the service. Total charges incurred by the customer. Churn, whether the customer churned yes/no. Each row represents a customer, and the columns provide detailed information about their profile and usage. Insight, from the .head output, we can already start forming some hypotheses. Customers with higher monthly charges or total charges might be less likely to churn. Customers with longer tenure might be more loyal. Certain service offerings, e.g. online security, streaming TV, might influence churn rates. Payment methods or contract types could also play a role. These initial observations will guide our EDA and feature engineering steps. What can be potential next steps? You can try these suggestions below. Explore more rows, use df.tail to see the last few rows and ensure consistency. Check data types, use df.info to verify the data types of each column. Handle missing values, check for missing values using df.isNull.sum. Descriptive statistics, use df.describe to get summary statistics for numerical columns. Visual exploration, start visualizing key features using Matplotlib and seaborn. In our last step, we took a sneak peek at the dataset and got familiar with its structure. Now, it's time to roll up our sleeves and start transforming raw data into something machine learning models can understand. One of the first steps in this process is feature engineering, specifically encoding categorical variables. This is where we convert text-based categories like male or female into numerical values that algorithms can work with. Let us dive in and see how it's done. Why it matters: machine learning algorithms typically work with numerical data. However, real-world datasets often contain categorical variables, for example gender, yes/no responses that are not inherently numerical. Encoding these variables ensures that our models can process them effectively. By converting categorical data into numbers, we enable algorithms like logistic regression, decision trees, and others to make meaningful predictions. What to expect in this step? In this step, we'll focus on categorical variables like gender and partner. Use the .replace method to encode these variables. Convert text labels e.g. male/female into numerical values e.g. 10. Preview the updated dataset to ensure the encoding worked as expected. This step is crucial because it sets the foundation for more advanced feature engineering and modeling later on. Fun fact: did you know the process of converting categorical variables into numerical values is called encoding? There are several methods for encoding, such as label encoding, one-hot encoding, and ordinal encoding. Each method has its own use case depending on the nature of the data and the problem at hand. For example, if the categories have no inherent order like male vs. female, we use simple binary encoding 0/1. If there's an order, for example low, medium, high, we might use ordinal encoding. Real-life example related to this step. Imagine you're working for a telecom company, and you need to predict which customers are likely to churn. One of the key features in your dataset is gender. Since most machine learning algorithms can't directly process text labels like male or female, you need to convert them into numerical values. By encoding gender as 1 for male and 0 for female, you allow the model to recognize patterns related to gender without losing important information. For example, if your analysis shows that female customers are less likely to churn, the model will pick up on this trend because it now sees 0 female as a predictor of lower churn rates. Mini quiz time. Let's test your understanding of encoding, students. Question 1. Why do we need to encode categorical variables before feeding them into a machine learning model? A. Because machines love numbers. B. Because categorical variables are too complex for models to handle. C. Because most machine learning algorithms require numerical input. Question 2. Which of the following is not a common method for encoding categorical variables? A. Label encoding. B. One-hot encoding. C. Binary encoding. D. Text-to-speech conversion. Drop your answers in the comments. I'm excited to hear your thoughts. Pro tip for you. When encoding categorical variables, always think about the nature of the data. Is there an inherent order? Are the categories mutually exclusive? Be cautious with label encoding for nominal categories with no order. Using label encoding might introduce unintended relationships between categories, e.g. male-female. Consider using one-hot encoding for nominal categories to avoid introducing false relationships. What's happening in this code? This code block performs the following tasks. Encoding gender, uses the .replace method to map male to 1 and female to 0. This converts the gender column from text labels male-female to numerical values 1, 0. Encoding partner, similarly, maps yes to 1 and no to 0. This converts the partner column from text labels yes/no to numerical values 1, 0. By replacing text labels with numerical values, we make the data compatible with machine learning algorithms. The output shows the first few rows of the dataset after encoding the gender and partner columns. Gender, male has been replaced with 1. Female has been replaced with 0. Partner, yes has been replaced with 1. No has been replaced with 0. For example, row 0, gender is 0 female, and partner is 1 yes. Row 1, gender is 1 male, and partner is 0 no. This transformation makes the data ready for further analysis and modeling. Insight. By encoding gender and partner, we've taken the first step toward preparing our dataset for machine learning. These encoded columns can now be used as features in classification models to predict customer churn. As we continue with feature engineering, we'll encode other categorical variables and explore additional transformations to enhance our dataset. Potential next steps and suggestions that you can try: encode other categorical variables, continue encoding columns like dependence, phone service, multiple lines, etc. Handle missing values. Check for missing values in the dataset and decide how to handle them, e.g. imputation or removal. Feature scaling. Normalize or standardize numerical columns like tenure, monthly charges, and total charges to ensure all features are on a similar scale. Create new features, supercharging our data. Encoding more categorical variables. So, we started the process of encoding categorical variables, transforming text labels into numerical values that machine learning models can understand. Now, it's time to supercharge our dataset by encoding even more features. From dependence and phone service to internet service and beyond, we'll convert all relevant categorical columns into numbers. Get ready to see your dataset come alive with meaningful numerical representations. Why does it matter? Encoding categorical variables is a critical step in preparing data for machine learning. By converting text-based categories into numerical values, we enable algorithms to identify patterns, make predictions, and uncover insights that would otherwise be hidden. This step ensures that every piece of information in our dataset is usable and contributes to building accurate churn prediction models. What to expect in this step? In this step, we'll continue encoding categorical variables across multiple columns. Use the .replace method to map text labels to numerical values. Handle different types of categorical variables: binary, ordinal, nominal. Preview the updated dataset to ensure all encodings are correct. By the end of this step, our dataset will be almost entirely numerical, making it ready for further pre-processing and modeling. Fun fact: did you know the way you encode categorical variables can significantly impact model performance? For example, using label encoding on ordinal variables, e.g. low, medium, high, preserves the order, while one-hot encoding on nominal variables, e.g. male, female, avoids introducing false relationships between categories. Choosing the right encoding method is like selecting the perfect tool for the job. It ensures your model interprets the data correctly. Real-life example related to this step. Imagine you're working for a telecom company, and you need to predict which customers are likely to churn. One of the key features in your dataset is internet service. If you leave this column as text labels DSL, fiber optic, no, most machine learning algorithms won't know how to interpret them. However, by encoding internet service as numerical values, e.g. DSL1, fiber optic 2, number 0, you allow the model to recognize patterns related to internet service type. For instance, if customers with fiber optic service are less likely to churn, the model will pick up on this trend because it now sees 2 as a predictor of lower churn rates. Mini quiz time. Let us test your understanding of encoding categorical variables, students. Question 1. Why might encoding internet service as 1, 2, 0 instead of 0, 1, 2 matter? It doesn't matter, the order is arbitrary. B. It matters because the order reflects the quality of service, e.g. fiber optic DSL no. C. It matters because machines prefer smaller numbers. Question 2. Which of the following is an example of ordinal encoding? A. Encoding yes no as 1 0. B. Encoding low medium high as 1 2 3. See encoding male female as 10. Drop your answers in the comments. I'm excited to hear your thoughts. A pro tip for you. When encoding categorical variables, always consider the nature of the data. Is there an inherent order? Are the categories mutually exclusive? Be consistent in your encoding approach. For example, if you encode yes as 1 in one column, stick to that pattern throughout the dataset. Document your encoding mappings. This will help you and others understand what each numerical value represents when interpreting results. What's happening in this code? This code block performs the following tasks: encoding dependence, maps no to 0 and yes to 1. Converts the dependence column from text labels no yes to numerical values 0 1. Encoding phone service, maps no to 0 and yes to 1. Converts the phone service column from text labels no yes to numerical values 0 1. Encoding multiple lines, maps no phone service to 0, no to 1, and yes to 2. Converts the multiple lines column from text labels to ordinal numerical values, preserving the order of service availability. Encoding internet service, maps DSL to 1, fiber optic to 2, and no to 0. Converts the internet service column from text labels to ordinal numerical values, reflecting the quality of service. Encoding other columns, online security, online backup, etc., handles special cases like no internet service by mapping it to 0. Ensures consistency in binary or ordinal encoding based on the nature of the data. Encoding contract, maps month to 0, 1 year to 1, and 2 year to 2. Converts the contract column from text labels to ordinal numerical values, reflecting contract duration. Encoding paperless billing, maps yes to 1 and no to 0. Converts the paperless billing column from text labels to binary numerical values. Encoding payment method, maps different payment methods to unique numerical values 1, 2, 3, 4. Converts the payment method column from text labels to numerical values, ensuring each method is distinct. Encoding churn, maps no to 0 and yes to 1. Converts the target variable churn from text labels to binary numerical values, where 0 represents non-churned customers and 1 represents churned customers. By replacing text labels with numerical values, we make the entire dataset compatible with machine learning algorithms. The output shows the first few rows of the dataset after encoding all specified categorical variables. Dependence, no has been replaced with 0. Yes has been replaced with 1. Phone service, no has been replaced with 0. Yes has been replaced with 1. Multiple lines, no phone service has been replaced with 0. No has been replaced with 1. Yes has been replaced with 2. Internet service, DSL has been replaced with 1. Fiber optic has been replaced with 2. No has been replaced with 0. Online security, online backup, etc., no has been replaced with 1. Yes has been replaced with 2. No internet service has been replaced with 0. Contract, month to month has been replaced with 0. 1 year has been replaced with 1. 2 year has been replaced with 2. Paperless billing, yes has been replaced with 1. No has been replaced with 0. Payment method, different payment methods have been mapped to unique numerical values 1, 2, 3, 4. Churn, no has been replaced with 0. Yes has been replaced with 1. For example, row 0, dependence is 0 no, phone service is 0 no, multiple lines is 0 no phone service, etc. Row 1, dependence is 0 no, phone service is 1 yes, multiple lines is 1 no, etc. This transformation makes the dataset fully numerical, ready for further analysis and modeling. Insight. By encoding all relevant categorical variables, we've transformed our dataset into a format that machine learning algorithms can easily process. Each encoded column now represents meaningful numerical values that capture the essence of the original text labels. This step is crucial because it ensures that our models can identify patterns and relationships within the data, ultimately helping us predict customer churn accurately. Potential next steps and suggestions that you can try: handle missing values. Check for missing values in the dataset and decide how to handle them, e.g. imputation or removal. Feature scaling. Normalize or standardize numerical columns like tenure, monthly charges, and total charges to ensure all features are on a similar scale. Create derived features. Explore creating new features, e.g. total services subscribed, tenure in years, to capture additional insights. Split the dataset. Divide the dataset into training and testing sets to evaluate model performance. Explore correlations. Use correlation matrices or visualizations to identify relationships between features and the target variable churn.